Hi, my name is Julia Silge, and I'm a data scientist at Stack Overflow and the author of Text Mining with R, a Tidy Approach. In this video, I'm going to demonstrate how to use R and tidy data principles to analyze text, how to take some raw text, do some initial exploratory data analysis, and then train a structural topic model using the STM package. We're going to be using a collection of Sherlock Holmes short stories as our text in this tutorial. I'm going to be working in IBM's cloud environment for data scientists, the data science experience. So I'll demonstrate how to implement these kinds of tasks working in a browser with my code and packages and everything like that I need installed on a container-based infrastructure on IBM Cloud.
All right, let's get started. So I've logged into my IBM Cloud account here, and I'm on the data science experience part of the platform. And I have gone up, and you can click on Tools, and then I chose RStudio. And now here I'm on, I'm in RStudio server, which is running here on my in a container on my account, and I'm in my familiar environment here, and am ready to get started with some text mining. That's what we're here to do, right? All right, so I'm gonna go up here and I am going to open our markdown file. I'm going to be working in our markdown here today. I'm going to delete most of this, and then let's you know what, we're working with Sherlock Holmes stories, so let's give this a title of The Game is Afoot. All right, and let's save our file here in my project that I made. So game is afoot. All right, so I've got my my file here that is ready. So the first thing we need to do is we need to get our data downloaded and prepped a little bit. So let's get that started. So I'm going to be using in this tutorial a data set of Sherlock Holmes short stories that are available. They're public domain, and they're available through Project Gutenberg, the Project Gutenberg website. So in R, you can access Project Gutenberg works through the Gutenberger package. This is developed by David Robinson, and it has a function called Gutenberg download. Now, you can pass various things to this, but one of the things you can do is the Gutenberg ID. And I, ahead of time, went to the Project Gutenberg website and found the ID for the works that we're looking for. This is the Gutenberg ID for the Sherlock Holmes short stories that we want to do. So let's download that and assign it to something here. So so what's happening is that we went to one of Project Gutenberg's servers and we downloaded this text. So now it is stored in Sherlock Raw here. So we've got two columns: Gutenberg ID, which is that same number from before, and then the text, which is the text that we're going to be analyzing here today. So let's do some prepping of this text for some analysis. So I looked at this text on the website, and I noticed there are 12 short stories in this collection, and I would like to analyze differences between these 12 short stories. So what I need to do is I need to make a new column that is going to annotate the text and tell me where the stories are. The stories all have titles before them that say things like Adventure 1, Adventure 2, Adventure 3. So we are going to use, oh, you know what? I need to load a few more packages here. So let's load dplyr and tidyr and stringer. I'm not loading the tidyverse package altogether because of some issues with the IBM cloud environment, making that a little challenging. So I'm going to load them all separately instead. So let's load all these guys here. All right, so we're good. So now, so you can connect to data via sparklyr in this, but I have that turned off right now so that I can have some different packages. So let's use string detect, and let's say we want to detect in that text column, we want to detect when it says adventure in all caps. And in those lines, we want to keep the text, and the other lines we want to just have it be NA. So we can see here what's happening is we're detecting when something is says adventure in all caps. So let's count story. And we can see that we now see all the places where it says adventure, and there's the 12, the names of the 12 short stories. So that is great. What we want to do is we want to fill down this column that is going to tell us what story each of these texts is for. So we're going to use fill from the tidyr package to fill that column down until it gets to a new value. Then it will fill down and so forth. And you know what? We do not need that first little bit of preliminary information. When we had the adventures of Sherlock Holmes right here, we don't need that first information because that's not really part of one of the stories. We're not interested in that. So this will give us some information that we need. The last thing that let's make the story right now is a string, but let's make it into a factor, because when we go to plot these things, it's going to plot them in alphabetical order, but we want to plot them in the order of they are in the story. So that is, we can, like adventure 1, adventure 2, adventure 3. So we can do this by setting the factor levels by the order that we find them in, and that will look a little something like this. So let's make this Sherlock. So we are taking our raw text and we're doing some annotating so that we can see how things are going. So we have our text, and now we have a story. We have a story column. See now that the story is in order from 1 to 12, and that these are how many lines each one of the stories has. So we've got that going, and then the next thing we want to do is we want to take this text data set we have and transform it to a tidy data structure, to a tidy text data frame here. So let's take Sherlock again, and let's annotate this with another new column. Let's call it line. This is going to keep track for us which line every word is coming from. So we're going to say this is line 1, this is line 2, and so forth throughout the whole collection of short stories. After that, let's use the unnest tokens function, and let's unnest into the word column out of the text column. So instead of having one line per row, we're going to have one word per row. So let's see how that works. So remember before we had a text column that had a whole line of text, but now we have a word column. And in line 1, it said Adventure 1, A Scandal in Bohemia. And then it says, To Sherlock Holmes is how A Scandal in Bohemia starts, and so forth. So we've done it. We have transformed this to a tidy text data set. We're going to be doing topic modeling, so we need to remove stop words. That's an important thing to do when you go about doing topic modeling. I'm going to do that here with an anti-join, and I'm going to use the stop words data set that is in the tidy text package. So let's do this, and let's assign this to tidy Sherlock. So now we have a tidy data set of the Sherlock Holmes stories that we have here. So now we no longer have the stop words in there. Let's count the words and see what are the most common words are here. So this is after we have removed a big, fairly liberal set of stop words. It's going to remove a lot. And what we have here, the next is time, door, matter, house, hand, night. But notice, you know what? Look at that. Look at Holmes. This is about 3 times more common than the next word, and that's going to have a big effect on our topic modeling. So let's remove that as well. That is not going to be so useful, and is going to have a not so good effect on our topic modeling. So let's look at it one more time. So now the word Holmes is gone as well. So there we go. We have done it. So we have taken our text. We did some annotating of what it is that we wanted to be able to know about this text, and then we tidied it. So next, let's do some exploration of tfidf, because what we have here is basically 12 documents in this set of short stories. So what we can do is use tfidf to see which words are important in which of these stories. This will be a good thing to explore before we go ahead and do the topic modeling. And we can implement it without too much hassle using tidy data principles. So let's take our tidy Sherlock, and the first thing we need to do is we need to count how many times was each word used in each story. So let's count with two arguments, story, word, and then let's say sort equals true. So let's look and see what that is. So here we've got, in this first, in the adventure of the noble bachelor, the words saint, Simon, and Lord were used this many times. And then we've got the adventure of the copper beaches, and we say Miss Rucastle, and so forth. So these are all the counts here. So now if we want to calculate tfidf, we're going to use the bind tfidf function from tidytext, and the first argument is the data that we're piping in, and then after that we're going to pipe in word, and then that's the term, the word, and the next one is the document. The next one is the document column, and that in this case is story, and then the last one is the counts, and that here is also called n. So we're going to call it word story n, and let's run that. Let's see how that goes. So here we have now calculated tfidf, and tfidf. So what this statistic tells us is how important is this word to this document compared to the other documents in that collection. So let's group by story, and let's take the top 10 words in each story. So we're taking the top 10 highest tfidf words in each story. Now we can, let's make a little plot so we can visualize this and see what it is that it looks like. So if we want the words to show up in the plot in a reasonable fashion, we need to make this into a factor. We don't want them to show up in alphabetical order. We want them to show up in tfidf order. So let's make this a factor in order of tfidf. And now let's pass this to ggplot. So I need to load the package ggplot2. So let's say ggplot, and what are we doing here? What do we want to do? We want to make a bar plot that has word and tfidf on it. So let's do this here. Word on the x-axis, tfidf on the y-axis, and then let's make this in different colors so that it's a little easier to parse. We're going to make this a bar plot. So let's say geom_col, and then we don't need to see the legend because that's not the kind of plot we're making. Now, we don't want all of these stories all plotted on top of each other. We want to see each one in a separate little facet or a subplot. So let's facet by story and say scales equals free. And then the last thing we want to do is that we want to flip this so that we can read the words, so that it is flipped on its side. So let's look at this plot and see how it turns out. Let me put this here for you all. So okay, this is great. Is it possible for us to read all the titles? Okay, so for example, A Scandal in Bohemia is the first story, and we see that the most important words in this story compared to the others are, we see Irene Adler in this story. It's about a photograph. It's about the king, and these are all the important things from that story. If we look at a different one, like The Adventure of the Blue Carbuncle, this is a mystery that involves geese. Goose and geese are important. Bird are important in this story, but were not in any of the other stories. And so that's why it has high tfidf. We see lots of proper names and people and places in these words. Opium is over here, and the man with the twisted lip. In The Adventure of the Engineer's Thumb, we see hydraulic. So these are the words that are characteristic for these documents in this collection of documents. So looking at tfidf is a great exploratory tool before you get started with topic modeling. Speaking of which, I think it is time for us to get started here. So let us implement some topic modeling. So we are going to be using the STM package to do our topic modeling. We also are going to load the Quantita package, which is another great text mining package. We're going to use that as the data structure that we're going to use as the input to the STM topic modeling. So let's take our tidy Sherlock, and what we need to do is we need to make a Quantita document frequency matrix. This is kind of like a document term matrix, but it's a specific implementation of that kind of idea. So first we're going to do our counting like so, and then we are going to cast to DFM. So we need to say the document, we need to say the term, and then we need to say N, what it is that we're going to do here. So this is going to, oops, that didn't work. Did I not? Let's see if I may not have loaded this package. Okay, now it works. So now that I loaded Quantita. So now we have a document feature matrix that has 12 documents, which is what we were looking for, and this many features, which means words in this case. So let's define this as part of the Sherlock. Let's say this is the Sherlock DFM, which, like I said, is kind of like a document term matrix. And let's get that done. So now we have that saved. And now what we can do is we can train our topic model. So we're going to use an STM. So I'll just show you this here. So it comes from the STM package, and we can call it like this. So we're going to say we pass it the data. So we're going to pass it the DFM. Let us, I experimented a little bit with this in preparing for this video, and I'm going to say we're going to do a 6 topic model. So, and we're going to say this is the kind of initialization that we're going to do. So let me start this running, and then while this is a slightly more computational part of this process. So while it runs, I'm going to say I mistyped it, sadly. It's going to be topic mode, I guess, for the rest of this video. So I am a big fan of these STM topic models because it's easy to install. It does not have anything like an RJava dependency, and they are quite fast compared to other implementations of topic models in R because it's written in C++ under the hood. And the results that I have been getting as I've been experimenting with this have been really great. So it is going to go through a number of like an initialization here. It is then going to go through a number of iterations as it goes through and tries to fit the topic model. So what a topic model is doing is a topic model is saying, okay, we are going to say how many topics do you think there are in your text? Oh, and then we're going to be basically doing unsupervised machine learning to say which words contribute to which topics, and then which topics contribute to which documents. So there's freedom in this model for different balance of words. Like words can contribute at different proportions to different topics, and then topics can contribute in different proportions to different documents. So we're going to see what results we got here. So we see we went through the topic model fitting procedure, and it is now done. So we can do a summary of topic model. Oh man, I'm so sad that I mistyped that. We're gonna do that because man, I don't want to refit it again on the video. Okay, so here's a summary. This is like a print method that we have in here. But what I really want to do is I want to tidy this because I like to deal with things in a tidy data structure so that I can plot them using ggplot2 easily, so I can use dplyr to handle the things that are going on. And in tidytext, we have a tidying method for this kind of topic model. So we can look at the beta matrix. What the beta matrix does, it is saying what are the words that contribute to each topic. So let's look at that and make a plot. So here's what we're going to do. We're going to group by topic. Remember that we said we said we're going to have 6 in this model, and let's take the top 10 again. Let's just look at the top 10 words that contribute to each topic. So we're going to group by topic. We're going to take the top 10 terms or words in each topic. All right, so we're gonna make almost the same plot. So I'm actually gonna go up and copy this and put it down here. And what we're gonna do here is we are going to now we now have term, and so term is going to be what we're just looking at, and we are going to put beta on is the thing that we're comparing, and the faceting now is topic. So we're saying which words contribute the most to each topic. So let us look at this. Whoops, I have a story in there somewhere. Fill equals topic. There we go. Let's try again. All right, let's wait for that plot to come up. Excellent. All right, let's look at this a little bigger. So here we can see which words are contributing the most to which topic. So interestingly, we see some proper names again, where there are some words that are names that are so dominant that the topic modeling procedure gave them a lot of weight. We see things like Saint Simon. But then we also see things here like father and time. In topic 5, we see things like miss, door, house, matter, night. These seems like spooky Sherlock Holmes mystery kind of words. Topic 2, we're back to the goose. We're back to the goose here. Topic 3, we have things like street, woman, photograph. So there are other kinds of words here. So 3 has quite a few words there that are related to women. So this is interesting. So we're looking at what words contribute the most to which topics. So that's one kind of probability that we get out of these kinds of this modeling procedure. The other kind that we get is called gamma. And so this we tidy the same topic model, but we're going to say we don't want the beta matrix, we want the gamma matrix, and we're going to say that we know the names here because we have it in the Sherlock DFM. So now let's look at this. So the TD gamma, this is, we're taking the other matrix. So we're saying how in this document, how much did this topic contribute to it? So that's what these probabilities are measuring. So let's make a probability here. So a plot here to show these probabilities. So let's see. I'm going to say TD gamma, and we are going to, because we only have 6 topics this time, so we don't really need to take a top N or anything like that. So we're going to put gamma on the we're going to say gamma. We're going to make a histogram here of gamma. So let's say gamma. Let's say the fill is going to be the topic so that we can see it a little more easily. And then we're going to make a histogram. So let's do the histogram, and we don't need to see the legend in this case. And let's we don't want to see the histograms all on top of each other. We want to see the histograms for each topic separately. And there's how many topics? 6. So let's make this 3 and look at what this looks like. All right, let's wait for this to come up. All right, pretty interesting. Okay, so let's look at what this does. What this plot is telling us is that our topic modeling procedure did a bang up job of taking the stories and putting them into one topic. So look at this gamma probability is the probability that a document belongs in a topic. So let's look at topic 1. There are 2 stories that have probabilities close to 1 that they belong in that topic, and then 10 that do not. In topic 2, there is 1 story that belongs in that topic and 11 that do not. So we see here that it's 1, 2, 3 here, 2 here, 2 here. So the topics are all being associated very strongly with stories, either 1 to 3 stories, and then not associated with other stories. Topic modeling doesn't always work like this. This is probably because we're dealing with such a small number of documents, and that the number of topics is actually only half the number of documents. So this is what has happened when we've done this kind of modeling. If you do modeling with, say, a much larger data set with a much larger number of documents, you end up with different kinds of results, but this is how you interpret them. What this gamma is telling you is how likely is this document to belong to this topic. All right, so that is that for now.
So we did it! We trained a topic model on this data set of Sherlock Holmes short stories, and we were able to understand which stories are more similar and which stories are focused on which topics. You can read my blog post for more details on this code, and check out the Shiny app I made to explore the results of our statistical modeling of these stories.